Okay, Sohail, let's try to solve this question, which is a match the following question in which multiple options can also be correct.
ओके जैसे कि इन क्वेश्चंस में हम देख सकते हैं हमें पीछे से प्रोसीड करना चाहिए. लेट्स सी वी नो बोरेट वी टेस्ट वी नो रिडक्शन white fumes hydrolysis. Okay, let's move because in JEE some reactions will be there which we are not aware, but we have to give the answer it. We can answer it by using the back approach. Okay. Firstly, let's start doing the easy part we should take. We know these reactions BBr3, it is known unknown. This reaction is we are unknown with because it is borax is there, it is reacting with copper 2+. Okay, so it is a borax bead test. We can generally see it by easy. It is so easy. So B, firstly the P option matches, so P option will be the match of P. Now we will see Q part for B option. So it is also showing that it is a reduction, so we gain or loss of electron will be there. We can see that there is nothing changing because the copper state is 2+,
and in the final product it is also 2+.
So there is no oxidation or reduction, so Q option will not be there. So now check R option for B. Is there any white fumes?
No, not at all, because copper borate is a solid substance.
Yeah, it is a bead, so it is not forming any fumes, is not there, so this one cannot be the answer. So
and hydrolysis can also not be the answer because nowhere hydrogen H2 is being attacked.
Yeah, so S will not be also the answer. Now we will solve the next part. Now proceed to the A1. Proceed now check A part. So proceed to P option. It is not a borax bead test. It is generally we can see it easily. Okay. Now move toward Q. It is a reduction or not?
Yes, absolutely. Yes, it's a reduction process.
Because boron is in the state of
+3.
And final product
it's 0.
So it is a reduction process. Q will be our answer. Now move toward R. It is not a fume, it is an element.
Yes.
And in S, it is S or what?
It cannot be the answer because H2 is not involved in the reaction.
Yes, so S will not be there. So answer will be Q. Now move towards the next option, which is our C part. Now C part, we see that AlCl3 plus H2 gives HCl. So firstly let's check the P option. It is borax bead test?
No, not at all.
It's Q, reduction or not? Let's check it. There is aluminium in +3, but there is no aluminium here, and H2 is in the same +1 and +1. So there is no reduction. So Q will not be there. Now we will check the white fumes. Let's check R. As HCl in the vapor form exists in the white fumes, so R will be the answer. And it is hydrolysis or not?
Sohail, will Al2O3 will also be found in the product?
Al2O3, yes, it is also product, but it is not given in the option.
Okay.
So we will consider HCl only.
Okay.
So now move toward the S option for it. Yes, it is hydrolysis because H2O is involved. So its option will be R and S will be the answer. Now move toward
D option.
Firstly, we will check this is a borax bead test or what? No, it is not borax bead.
Because nowhere boron is there?
Yes. Now move towards Q. Reduction is there or not? The chromium is in the
the oxidation state is reducing from +3 to 0.
+3 and is changing to 0. So reduction is going. So Q will be the answer, and R, chromium is an element, so it is not forming any fumes or what. So R will not be there. And hydrolysis, because no H2O is involved, so it will not be a hydrolysis. So in this way we can see that when the match the column is multiple correct, we have to check every option. Okay.
Because the chances of error in such type of questions are very high.
Yes, so we have to write all the options and cut it and tick it. That's the only way to get the answer correct.
So Sohail, let's try solving this question. Note that it is a previous JEE Mains question and it is based wholly upon that how important chemical compounds are prepared.
So now proceed with this, type this from these processes: contact process, Ostwald process, Deccan's process and Haber's process. Firstly, we should know that contact process is used for the manufacturing of
HNO3.
yes, and this Ostwald process is used for the manufacturing of
H2SO4.
yes, and the Deccan's process is used for the manufacturing of
Chlorine gas.
chlorine, and Haber's process is used for the manufacturing of
Ammonia.
ammonia. So firstly, it is very easy to see that the manufacturing of ammonia, there's 2 nitrogen and 3 hydrogens in the presence of catalyst Fe and molybdenum kiss 2NO3.
So we can directly match it to
Directly.
H. S.
D will directly matches to S.
S.
Now this part is completed. Now we will see that C part. As we see that it is the production when this Ostwald process is going on, this step came in the second last step of the production of H2SO4.
When we did the product formed in this reaction, which is SO3 with water, we get H2SO4.
Yes. So we get the C matches with, finally it matches with Q. Now C part is completed. Now we move toward B part. As we know, the chlorine is producing, so we can guess that it is Deccan process. Okay, so P will then matches with R. Now we move towards A part.
Okay.
So A will matches with, so this process is left will be HN3 and contact process. Here NH3 is using SO2 and platinum is a catalyst, NO is producing, so A will matches with, finally it will matches with P.
You should remember one thing, that to solve such kind of problems, you should be thorough with the manufacturing process of all the major compounds.
Yes. If you know the products, how they are manufactured, then you are very easily to answer it.
So Sohail, let's solve this easy looking question in which we have to tell the number of sigma bonds present in the structure of borax.
Yes, firstly we should know the formula for borax. It is Na2B4O7.10H2O, but its correct formula is Na2B4O5OH4.8H2O.
Yes.
Now we will draw the structure of borax. So it is boron, oxygen, nitrogen, oxygen, boron, O, H, O, B, then O, again B, then O, B, O, H, O, H, whole bracket, minus charge, 2 Na plus and dot 8H2O. So we have to calculate total number of sigma bonds. Okay, and this one is O. Okay, now let's start calculating the sigma bonds.
So every boron is connected to another boron by oxygen.
Yes, so first, second, third, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15, 16, 17, 18. The students only write that there is 18 sigma bond.
Yes?
Yes, and they forget there are 8 H2O is also present there.
Okay, we have to consider them also.
Yes, they are asking total number of sigma bonds.
Okay.
So each H2O consists of 2 sigma bonds. This is 1 and this is 2. So 8 will consist of 8 into 2, 16 sigma bonds. So total number of bonds will be,
the sum of 18 and 16.
yes, it will be 34 sigma bonds total in the borax.
So this is an easy question but a tricky one.
Yes.
So Sohail, let's solve this question in which we have to find the number of atoms in the same plane in the structure of diborane.
Yes. Here we have to find the maximum number of atoms in the same place in the diborane. So firstly we have to write what is diborane. We have to know it. So
It is
diborane.
B2H6.
Yes, it is B2H6. So now we will draw its structure. It's 3 center 2 electron bonds. Then this wedge and dash structures. And we will see that we write the answer as this is, we consider this as a plane, okay, this one, and we write the answer is 4, and but this is the wrong.
But why Sohail?
We forget that it is given that maximum number of atoms. We should rotate this diborane, so see that it can be, there can be any more number of atoms can also be in one plane, so we have to check it. Says if we draw the figure in a different orientation, we will get this was this and this. So when we rotate, this is up and below. If we rotate this one about this, then this can be in the same plane, and boron is a circular one, so it can be in any plane, okay. So when we have this plane, this one, this is the plane, okay, and this hydrogen are, so now it contains the number of atoms 1 2 3 4 5 6. So here we are getting 6 atoms. So this is the maximum number of atoms, okay. This is a misconception. The student made that is wrong, and this one is right.
So to solve this kind of problems, you should be thorough with the structure of compounds.
Structure, yes, we have to visualize it.
So Sohail, in this question, we have to tell the difference in the products when greenish yellow gas is treated with caustic soda first in hot conditions, then in cold and dilute conditions.
Yes, in this question we have to tell this only. Okay, firstly we should know what is caustic soda. Okay.
Caustic soda is NaOH?
Yes. When NaOH reacts with a chlorine in the cold and dilute environment, which I've already mentioned in the theory part also, it gives NaCl, NaOCl plus H2O. And when again NaOH means caustic soda and chlorine reacts in the hot and the concentrated environment, okay, then we will get NaCl, NaClO3 and H2O. So they are differing in the one product. Which is that one product? This one is NaOCl and NaClO3. And other two products are
Exactly same. And students, one thing you should also remember that the color of Cl2 gas is greenish yellow,
yes,
and that of fluorine is yellowish green.
Yes, he is right. This is greenish yellow gas, means this is chlorine and this is chlorine that I have mentioned in this question, okay.
And the color of fluorine is yellowish green.
Yes.
So Sohail, let's do this question in which a compound A, which is used in home signal, is treated with water to produce a compound B, which is called slake lime, and also a gas which has a smell of rotten fish. So we have to determine A, B and C in this question.
So firstly we should know the compound A, which is used as home signals, okay. The compounds which are used as Ohm signals are Ca, C2, Ca3P2. It is mentioned in NCERT also.
Which is calcium carbide and calcium phosphide.
Yes. And when it both reacts with water, what will be the products? Let's see. And it is given that slaked lime will be the product, means calcium hydroxide will be the product, and C2H2 will be produced when it reacts with calcium carbide, and when it reacts with calcium phosphide, then we will get CaOH whole twice, means it is slaked lime, and we get PH3.
Okay.
So for the A we have two options, means CaCO2 and Ca3P2. We should see them.
So which one we should choose?
Yes. Then in the next part they are given that it produces slaked lime. But in the next part we see that it produces slaked lime. The slaked lime is produced in both these reactions. Okay.
Yes.
Now we move to the next point, when it produces a gas which is rotten fish smell gas. So here we see that this PH3 is rotten fish smell. Okay.
Yes.
That's why we can tell that CaCO2 is not our A, it is Ca3P2. So
Okay.
our A will be
Ca3P2.
Ca3P2, and our B will be,
Calcium hydroxide.
yes, it is already given in the question. It is slaked lime, and our C will be
We just mentioned that it will be PH3.
PH3, which is a rotten fish smell gas.
So by this we end this question.